All right. This is 7th of April, problem of the day, and this is walking robot simulation number 2. So I'm assuming it's very similar to yes. Oh no, it's a design thing. Okay, fine, fine, fine. A width by height grid. A width by height, okay. Is on the XY plane, with the bottom left cell being the origin. Oh god. And the top right cell being width. Oh, why would you do it like that? Fine. Top right cell being width minus 1, height minus 1. Does that make sense? Width minus 1. Oh, no, it doesn't make sense. Because this is referring to the x coordinate, not the row number. Okay. Width minus 1, height minus 1. Fine, fine. The grid is aligned with 4 cardinal directions. Yes, the robot is facing east and is at the origin. The robot can be instructed to move for a specific number of steps. Each step does the following: attempt to move forward. If the cell robot is moving out of bounds, it turns 9 degrees counterclockwise, so turning to the left, and tries to take a step. After the robot finishes... Wait, won't it just go along the borders forever? Okay. Implement the robot class. Robot int width height. Initialize the width by height grid. Yep, sure. Void step, so instruct to move forward this many number of steps. Okay. Get direction. Get position tells you the position, and then get direction tells you what way it's facing. See, in my mind, like this robot, Mr. Android over here, is gonna go like this. He's gonna go here, then go clockwise, go here, sorry, counterclockwise, and then go here, go counterclockwise, here, and then here, go counterclockwise, and it's just gonna go on a board, like along the circle, right? It's not gonna ever touch the inner, unless I misunderstood the question. Because it's always turning counterclockwise, and it only ever turns counterclockwise if it's about to move out of bounds. And I'm assuming you're allowed to go over the same square over and over again. So num, what's num? Num is the number of steps you might take. Ooh, so that means you can't just simulate, doesn't it? So yesterday we were able to go one step at a time. I don't think that'll work this time. But I also think this is more predictable than yesterday's because this one has no obstacles or whatever it was. Were there obstacles? Yeah, yesterday there were obstacles, right? Um, okay, yeah. So here you're like 6, 3 because it's a 6 by 3 grid. Then you step, then step. Oh, sorry. You step twice. 1, 2. You step twice. 1, 2. You get position. It's 4, 0. Yeah. Then you get direction. Facing east. Then you step another 2. 1, 2. Like you go here, then go counterclockwise. 1, 2. You step again for 1. Then you step for 4. You turn and go 1, 2, 3, 4, and you get position and you get direction. I can't tell if I'm being dumb, but I'm pretty confident that by the way this is talking, the way this question is written, you will only ever touch the outer border of cells. You're never going to go inside. Because you only ever turn when you're about to... Okay, yeah. I'm pretty confident. So, where's my OneNote? Whoops. Probably shouldn't show that. So this is POTD 2069. So if we have to... Do I have to actually initialize the grid? No, right? It's just passing in. I don't actually have to make a 2D array. Maybe I will, but I'm not sure. I guess conceptually speaking though, if you initialize with 6, 3, given 6 and 3, at least conceptually, even if we don't actually make the computer do this, we are creating a grid that is... Wait, did I do this the wrong way around? 3 rows. So 3 rows and 6 columns, because the width is 6. 3, 4, 5, 6. And we know our robot, the current direction is east. And we know our robot is at 0, 0. Right? And then, We do not, I know that, oops, I know that for sure we do not want to do one step at a time because one step might be 10 to the 5 things. What I will say is I believe we can calculate the number of cells in the outer row. I think that would be really helpful. I don't know why I'm coloring them all in, but here we are. Basically, it's the number of columns plus the number of columns plus the number of rows minus 2 plus the number of rows minus 2. So it's number of columns plus the number of columns plus the number of rows minus 2 plus the number of rows minus 2, getting rid of these two and getting rid of these two. So you get 12 plus 2 gives you 14, because 6 plus 6 plus 1 plus 1. Good. So we have a formula for that. So number of like border cells is equal to, what did I say? Number of columns. Width, I guess, is better. Width plus width. Width plus height minus 2 plus height minus 2. The issue becomes, what if height is 1? Can height be 1? Probably. No, it cannot. Why can't height be 1? I feel like height should be able to be. That would make the problem a little bit more interesting, but fine, whatever. Height can be at least 2, sorry, so this formula should work. Because it's, ooh, will it work? No, it won't. Not if you have exactly 2. Nope, it will work. Yeah. It would fail if height was 1, but it does work for everything else. Okay, so we have 2 lots of W plus 2 lots of H minus 4. So that's how many number of border cells there are. The reason why I think that's good is because for some K steps, we know that if you take 2W plus 2H minus 4 steps, you end up in the same place. That's why I thought that was a good idea. I don't actually need this first sentence. What this is, so for example, we said there's 14? So yeah, 12 plus 2, right? 14 things here. If I for some reason am here and I take 14 steps, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because there's 14 elements, going around, iterating through 14 times is going to take you back to where you started. So immediately what we can do is, if the number of steps is strictly greater than this guy, then you might as well mod it by this number. Because there's no point in going around in loops. You might as well just shorten the number into how many steps you're effectively taking. So the mod is a decent idea. And then from there, what do I want to do? There's a couple of ideas. You could keep track of like how many steps are left before you're about to hit like the end, like the board, like the actual corner. Steps to a corner could be something. Like let's say in this position, K is equal to 7, or we'll say 8. So I know that it's, 1, 2, 3, 4, 5, 6. I know that I should end up over here. If my position is 0, and then 1, 2, 3, and my, X and then Y, right? And my height is 0, then my eventual position should become 1, 2, 0, 1, 2, right? It probably would be smart to actually rotate around and actually make the top left become my starting point. I think conceptually it's the same thing. It's just for some reason they made it weird. That's fine. So if K is 8, I know, for example, that since I'm at 3 and I have a total of 6 columns, I should be able to predict that, okay, after 2 steps, I'll be at the corner, because I'm going east. So if my direction is east, or my direction is west, then, or maybe, if my direction is east, I'll do this in like each case. If my direction is east, then number of steps to the border is equal to the number of columns, my width, minus my like position, my x position. Do I have to minus 1 as well? Because 6 minus 3 will give me, yeah, so it's 1, 2 though. I need to subtract 1. And then yeah, so because I modded, I should only have to do this at most like 4 times or whatever, right? So yeah, steps to the, maybe not to the border, sorry, to the corner. Else, if d is equal to north, if we're going up, if we're going up in this direction, then, for example, if my position is 5, 0, I have 2 steps I could go. And I know that because my y coordinate is 0 and there's 3 columns. So it would be number of steps to corner is equal to, I don't know why I'm doing that, is equal to, what did I say? Height minus the y position minus 1. Else if it's west, number of steps to the corner is, so for example, this one is 0, 1, 2, 3, 4, 5, and then 0, 1, 2. So I have to look at the x coordinate, and I think I would do the x position minus the width, I assume, minus 1, because it's like this is now the bigger number. 1, 2, 3, 4, 5, and then similarly, else if d is equal to south, the current direction is south, the number of steps is equal to the corner is equal to is this flipped around, y pos minus height, because now y pos is the bigger number, minus 1. And then basically you basically run through this, you try to reach the corner until your remaining number of steps, k value, basically hits 0. So what do I mean by that? Let's say we're here, k is 8, and we have this sort of control flow, right? We ask ourselves, okay, we're facing east. How many steps to get to the corner? We would run through this, we'd get 2. So k would reduce to 6, and we would end up over here. My current direction would flip to north. We'd ask ourselves, okay, what is the number of steps required to get to the corner? The answer is 2 again, right? So this would reduce to 4, and we would get to over here. Then we would ask, okay, how many steps are required to get to the corner again? And we would say, well, we need 5, right? Because we would do this formula going west. We would get 5. But k, the current value of k is less than 5. So we know that we're not going to get to the corner. We're going to get a bit before. And so we should just move from this corner 4 steps to the west. 1, 2, 3, 4. And that means subtracting the x coordinate by 4. And we would get our coordinate. And we would be happy. So I think that's fine. And the idea is, because I modded, I'm not going to be going around in loops and loops and loops. I'm only going to do a maximum of 1 loop, which is, well, I have a formula, don't I? It's O of W plus H, which I'm assuming is completely fine because W and H is at most, that sum is at most 200. And then you're doing that, how many steps did they say? 10 to the 4 calls. So 0, 10 to the 4 times 200 basically, which is 2 times 10 to the 6. Which is not so simple really, but I think that's fine. I think that's legal. It might be a bit slow, but it will be fine. LeetCode should be fine with that. All right. So what do I want? Like I said, I don't think I really need the grid. I just need a current direction. I guess we will use strings because Python is nice with strings. Not always the case, but we'll take it. Do I want to keep it separate? I guess I could say current position is equal to 0, 0 as a list. That's fine. Keep it mutable. That should be fine. What else did I say? Anything else I have to initialize? So like I said, I don't actually have to initialize the grid. Yeah, that should be fine. Maybe I want to create like a, I should say self, shouldn't I? Self.w equals width, self.h equals height. Maybe I should just say, I don't know, I'm trying to be short, just use the whole word. Do I want to keep track of anything else? Did I say anything else? Maybe like an array to make flipping through the directions easier, like. Maybe some constants would be good. East equals 0. What comes after east? North. North equals 1. As in terms of if you turn anti-clockwise, not obviously that. And west equals 2. And south equals 3. So instead of saying east, we can say east. And we can say directions is equal to east, north, west, south. And changing directions, that's a private thing. Would be a matter of saying, I have to get the next index, so east, no, sorry, current direction, self.current direction, plus 1, mod that by the number of directions, and that's your index, and then directions at that index, self.current direction. Looks a bit complicated, but I'd rather have that in a sort of, or turn anti-clockwise. So yeah, we're just basically iterating across, because every time you turn from east, you go to north, from north you go to west, from west you go to south, and then the extra bit of complication is if you go from south to off the page, you want it to mod back to east, basically. So that's all that's doing. And then we access that index and we set the current direction. That's not too bad. Yeah, position, is it just a matter of, yeah, return self dot current position, and then get direction, return, directions to string, same idea, east, north, west. Technically these shouldn't really be global, it's a bit silly to do that, but it's fine. So same thing, but self.current direction, because this is the index that we are accessing. Very good. Okay, so we have these two, nice and easy, and then from there we have to apply our main logic. So num steps is equal to num steps to corner is equal to 0. Oh, they use num, not k. I don't know where I got k from. Anyway, while num is greater than num steps to corner. Do I know that? Or is it less than? Isn't it? It's less than. And I should make this like float infinity or something. And I'll just say self num border cells is equal to 2 lots of width plus 2 lots of height minus 2. And we said num mod equals self.num border cells. Fantastic. So that's this idea, right? The idea of like doing all this stuff. Yeah, and then we do this if statement. If self.current direction, is there a switch case in Python? There's like match or something, at least. this value. Oh man, is this gonna work? I'll write this out first. Self.width minus self. Current position at 0. I should use these. Hang on. X equals 0, y equals 1. Where am I? At x minus 1. Elif. Why am I wrapping it in brackets? This is not C. Lots of self.current direction is equal to north. Maybe I just have to say while num steps is greater than 0 or something, you know? And then num steps is what, height minus the y position minus 1. Elif self.current direction is equal to west, I assume I did next. Then this guy is equal to self dot no, it's the other way, isn't it? It's x position minus self dot width minus 1. Obviously I could say else, but might as well be explicit. This guy, you use y and you use height, and then if ooh, wait, I have to actually change the position as well. I didn't think of that. If number steps is greater than num steps to corner, I'm not going to write this very well, I can't really tell. If the number of steps I have to do total is greater, then I just have to change direction and move to that corner. But I already forgot which corner to move to. Well, maybe I can do something like, this is going to be a bit dumb, but self dot corner destination, whatever, is equal to, it's a bunch of, ooh, maybe I should make them tuples so that I just to make sure they don't change. I don't know. So from east, your destination is this corner over here. So it would be you would be the width minus 1 and 0, and then from north your destination would be here, which is the width minus 1, height minus 1. Then it would be 0 for like getting over here would be the destination going west. Maybe I should do this just to make it easier to read for myself. 0 and then height minus 1, and the last one would be 0, 0. The destination going south is 0, 0. So if this is the thing, then self dot, what is the current position, is equal to the list of self dot corner destination at index self dot current direction. I've lined them up, right? So if your direction's going east and you definitely will reach the corner, then happy days. I should say greater than, listen to that one, right? Yeah. So you set the current position, and you can also run the self dot turn anti-clockwise, because you know you're going to turn. Oh, what happens if do you turn before or after? You shouldn't. Okay, wait, this should be greater than only, because if they're exactly equal, if it's exactly equal to this, then this will work, but you shouldn't change direction, because you should only change direction when you're about to move off. Else, and this is the case where we got up here where like the number of cells, the number of steps left in total is less than the number of steps required to get to the corner. Else, and then I might just do one more trick where it's like self dot direction or displacement vector or something. Same kind of vibes. It's just I line it up so that it's like 1, 0 to mean that, you know, going east means I go to the right by 1, 0, 1, going north means I go up by 1, minus 1, 0, and 0, minus 1. Else, my displacement vector, the current displacement vector is equal to self dot displacement vector at self dot current direction, and then my self dot current position at index at the x coordinate is equal to the current displacement vector at the x thing plus equals, right? Plus equals multiplied by num, and same with the same with the y. This is getting a bit disgusting. I thought this would be clean, but now I feel like I could have structured things a bit better over here as particular. That's okay. The idea basically is, for example, if you're going west, let's say, you're going to pull minus 1, 0. So over here, you're saying minus 1 times the number of steps left. So minus 1, right? So we're going to the left, the x position we push to the left, and the y will just be 0 because this guy at y will be 0. So the y thing won't change. And then, you know, you can try that for each case. I didn't actually, and then the num should be set to 0. Here, num should also be set to 0. Here, num should be subtracted by the number of steps required to get to the corner. Yeah. Wait, current position is, yeah, just a list, and this is the, okay. I think I've just about done it. Num steps to the corner. Why did I make this? I don't really need to make this infinity, do I? Because I'm not actually using it. I thought I had to use it for the while loop, but... So we get the number of steps to the corner, which I back. I think this is fair game. And then from there we check. If the number of steps required is bigger than the number of steps to the corner, then we will subtract this off. Num will stay greater than 0, so the while loop will run again. We set the current position to be that corner, and we turn anti-clockwise. There might be an even cleverer way where you don't have to loop through, where you don't have to loop 4 iterations of the loop or whatever. But I would rather, this is clearer to me. Not necessarily very clean, but it's clear, like what else going on. And the number of loops is restricted to, 5 or something, 1, 2, 3, 4, 5. Like you're never going to go back to the same position because we modded. So we're keeping it relatively stuck, I guess. If the number of steps to the corner, yeah, get the corner destination, turn anti-clockwise, turn in this case, num minus equals number of steps to the corner. But if it's exactly the same, then very similar, num will be 0 because, I mean, you could also run this, but it will set num to 0. Maybe I will run that just because it makes it look more the same. Just to really show that, this is the same as this. This is the same as this. The only difference in these branches is there's no turn anti-clockwise. Else, if we don't have enough steps left to reach the corner, then you figure out what direction, based on what direction, you figure out how the numbers will be manipulated. You manipulate the position values, and then you set num to 0. And therefore, the while loop will break. I think it makes sense. Oh. Oopsies. Did I put a P in there? Oh, I did. Fair enough. Aw. Oh, my bad. Should be lowercase. Oh, this also failed, actually. So I said 5, 0. Wait, did I not change directions there? Because I reached the end of the... No. Okay, I do think I have a bug, actually, but I didn't expect... I wouldn't have expected it to happen here. So you went up to 4, 0. Null, null, null means step, step, step. You would have gone 2, 1, then 1, then 1, 2, 3, 4. Okay. So it went 5, 0, and then just never tried again. So what happened? After here, you went 1, 2. So it should have gone here, and then changed directions and gone like that. So the question is what happens when num steps the corner is 0? Should be fine. It will just, if number steps to 0 happens and num is greater than 0, which will be the case, then this will just be the same thing. Then you will definitely turn anti-clockwise. It should be fine. I don't understand what's going on. East up to 4, and then num steps, like num is 2 at the start, right? So you go across by 1. That gets you to 5, 0. And then you should subtract by 1 at that point. Maybe I should just print, hang on. Print num steps to corner is equal to num steps to corner. Num steps left, like total, is equal to num. Yeah, I'll just put a print at the very start as well, just to keep some white space. Yeah, so like it doesn't run. That's not good. It's increasing. So num steps left is 2. Num steps the corner is thing. So you get to that. Num steps is 2. Num steps the corner is 3. So you get to there. Num steps is 2. Num steps the corner is 1. Okay. So current position, current direction. If you're east, then your current position will become width minus 1, 0. Which is correct, right? 5, 0. And then maybe this is wrong. Print direction after turn is equal to self dot current position. Looks pretty good, I mean. Yeah. Hang on, let me just run the print statement. Whoa, what? Did I say current position? Oh, I said, I'm silly. Direction after turn is 1. North. Okay, so that did work. Total steps left, steps to the corner is 2. Yeah. I'll say finalized position. Okay, so it seems like it's turning correctly, which is nice. Finalized position is 5-1. Oh, wait, it is working. Kind of. Okay, so it's this massive slab at the end. Just to clarify, you go across by 2, then 1 up by 1. 5-2. Total number of steps left is 4. Num steps to the corner is 0. Yeah, because you're at the corner. So then you do turn by 2. So direction becomes 2 because it's west now, right? East, north, west, yeah. By 2. Number step. Oh, so the formula's wrong. Number steps to the corner is -2. It should be 6 or something. 5. 1, 2, 3, yeah. So I must have written the formula wrong. So we're going to the west. Is this wrong? Oh my god. Self current position is 5, right? That's what got printed out. Minus self dot width. I'll just print this real quick. Self dot current position x is equal to I did not think it would take this long. I don't know what's going wrong. Wait a minute. Ah, this should say 0, shouldn't it? Wait. Am I being silly? Yeah, because the destination is 0. So if you're here, you're trying to get to 0. Oh, I'm dumb. It would be same for this. So I unironically just wrote it wrong completely. Oh no, I didn't write it wrong. Wait, I did write it wrong. I tried to like follow a pattern and messed it up completely. I saw it correctly and then saw it wrong here straight afterwards. Good, that's really fun. Okay, well that's a fun bug to... What? 0, 2? Is it still wrong? So 0, you turn left. Total number of steps left, 1, 2, 3, 4. Number of steps to the corner is 1. Okay, so maybe it's not this. 1, 2, 3, 4, 5. So it's just from the corner to there, it's the width. Is it just the width? Ah, it's width -1, sorry. So I'm like tilted now, and this is height -1, which is the same thing as just, because we're at the corner, it's the same thing as just saying current position x, current position y, but I'd rather say width -1. I think it's a bit more clean. Oh, for God's sake. Damn. It's not even late. I have no excuse. There we go. Alright, I do want to check because I want to check the modding stuff. I want to get rid of the prints. Replace that with hash print. I want a case where you're like, okay, let me draw it. So let's say you've got so 1, 2, 3, 4, you got a 5 by 4. And you've got step, and you've got like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 10, 11, 12, 14. So there's 14 over here. So if you're over here and you go 12, that's the same as getting up to here. So I'll say 12 for step. Then I'll say get position and get direction. So this just makes sure that this is just to make sure that going south is also fine. I'm sure it is now, but oh man, what'd I do? Oh wait, this shouldn't be in brackets. What am I doing? What? Oh, it's because I put a white space in there. Cool, so it's able to go south. And then, that's what I say, 14, right? If I do 12 plus like 20, plus 14, plus 14, plus 14, plus 14, if I say 68, it should be the same answer, but just with the mod, so it should know not to loop through multiple times. Damn it. Come on, man. It's the same thing. What did I say, 68? After mod num equals, like, it should be the same number, right? Did I do the mod thing wrong? Or the calculation wrong? Is this wrong? Ah, it's -4, not -2. Because it's -2 within the bracket, you have to expand it out. Alright, I'm fairly confident. Despite some exception. Seriously? I have output as well. Oh no, this is, as in, no, this is my returned output. Sorry, I thought this was my, I thought it was like standard output. It's not. Damn, I didn't even get past 4. I don't really have as much time as I normally would like. That's great. Whoa, wait, so step, 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 get position. I get -17 straight away. Like, I get immediately hit with a negative instead of 4. How? How? What is it? 20 by 14. That's pretty large. But I can do some of the calculations. 20. Maybe I was cocky about 2W2H minus 4, right? Yeah. So 20 times 2 plus, was it 14? Yeah, 14 times 2 minus 4. I think I backed that formula, right? It's like you get the 2 rows from here, which is 2 lots of width, and then you have these 2 columns, but you got to get rid of 2 on each column because you already counted them, the corners that is. So you do, I think I backed that formula. So there's 64 in the thing. You go 32, step 32, 18, 18. So how many steps is that total? So I'll just write this down. So 64. And the number of steps you take is basically 32, 18 times 2. So it's 68. So yeah, naturally, if you were to think about it as just one call, it would be the same thing as just moving to the right by 4. Hence you get 4, 0. Why did I get -17, 13? That's so random. Why did I go negative? I thought I had managed to do it such that it couldn't go negative. Like, I thought doing this whole num steps to corner thing would stop me from spilling over the page. About to hit corner. Okay, I'll get rid of this. I'll say print current direction is equal to, maybe I'll say directions to string at self dot current direction. Do that here as well. Running step function num equals to num. That was just a bunch of tabs. This is gonna be really rough, but I only have to look at the. Sorry, I didn't use these. All right, so you got 32. I shouldn't. Sorry, I shouldn't have done that. Current direction is east. 1913. Does that sound right? Also 20 by 14, so I want to say no. 19 across 13 up. Given that the... Is this width? Yeah, width is 20. Yeah, that makes sense. Because it's 32, so you're going like from one corner to the other corner kind of thing. It's half of the total. So I think that makes sense. Then 18. You're going north. Okay, so I think this is the issue. I think... Oh, no. Number of steps left, num steps to the corner is 0. Yeah, that's expected. And then so you're going to turn without moving. Yes. And then finalized position is 1913. Because you went across by 19 up. Sorry, I didn't want this here. I wanted this. Do I want this outside the while loop? I don't actually know what I want. Finalized position is like the final, after all the turns are done. 1913, 113, because you went across by 1. So then this happens again. Number of steps to the left. Number of steps left. Number of steps to the corner is 19. Is that correct? That shouldn't be correct. It should be 1 or something, shouldn't it? Oh, crap. Bro, what am I doing? Okay, hang on. I need to generalize. I shouldn't have used the corner. I should have picked a random spot in here. Okay, when you're going west, I don't know. This is actually quite ridiculous for me. I'm slightly disappointed in myself. If you are here, going west, going to the corner. This, for example, this is 0, 1, 2, 3, 4. And height is 3. And this is 0 up to 3 as well, right? Answer is 4, because you take this guy and that's it. That's the whole thing. You subtract 0 from it because it's 4 minus 0. That's the difference in thing. I don't know where I got this from. My brain is not working very well. That should be the whole thing. And then self.current position, y. Same vibes. And let's confirm that, because clearly I do not have the mental capacity to do things without the diagram. So this, for example, is 0 then 1. This is 0 then 0. So yes, 1 minus 0 tells you how many steps to get from 1 to 0. That's precisely what difference is, isn't it? This is actually easier than going east and north. For some reason, anyway, try it again. How intriguing. I literally had this line, and then for some reason I thought it was really clever and decided to do something dumb. Get rid of that. Run it again, make sure there's no weird print statements or anything. Right, try it. Alright. 97 by 98. Okay, that's a bit unwieldy. Get position is 0. Get direction is east. 97 times 2 plus 98 times 2 minus 4. 386. Do I have mods on this? The 386 is the thing. Does mod work? Like if I just say mod? 0. Oh shit. Wait. No, but what would change? While num is greater than 0. Num would get modded and then it would just go out. And then this. Also 0. And this. Also 0. Okay, now I'm confused. Oh, because... Yeah, I get it. Because I'm acting as if it never moved, but it did move, and... You're joking. Is that... Wait, okay, so okay. So because it's modded to 0, I'm pretending as if it never moved, right? Because in my mind, that's logical. But in this very particular case where, like, you're at a corner... if you did move, then what happened is you basically went like this. You did a full revolution and went back to the corner. But your direction did change. If originally you were facing east, you're now facing south in this case. If you originally were facing north, you'd now be facing east, hitting this corner. If you were facing... Oh, it's because the conditions change. Oh my god. Oh, that's so mean, actually. Okay, hang on. So, because the thing is, for all my other code, if you hit a corner, you're already facing in this direction, you know? If you hit a corner, you're not going to change direction until it's time to move. I wonder if it's worth actually setting it to south. Is it worth setting the original direction to south? Because my code will naturally make you rotate anyway. And you might be better off... Oh, this is a bit of a gamble because I don't actually know if this is going to be legit. Lol. Oh, no, because it's a original... Ah, they're clever. Of course, because originally you're not actually setting it to south. It's a good thing they put that in the... Wow, so what do I even do? So there's nothing clean I can... There's nothing clean I can do, right? That's so crazy. The original... The great basic logic is there. I just... How do I deal with this? It's because, yeah... Setting the original thing to south would make the problem... would make it uniform. Like, the invariant would be true across any time. Like, the invariant that I will only turn when it's time to move. But except for the very, very start where you've already turned before it's time to move, you know? Like, every other place... I only turn when I reach a corner. I only turn when it's time to move again. But in the very, very first part, because we're initializing to east, I've already turned before it's time to move. That's the one discrepancy, and that's what's causing this error. Um, okay, so what's a no? Do I really have to code for it separately? Like, if it's the very first moment, if it's the very first step, I can do this really grossly, but sorry, equals false. If num is equal to 0, then return. If if move before self dot move before is false, then self dot moved before equals true. And also self dot current direction is equal to south. I'm basically trying to do the best of both worlds. It's like I want to be able to set the initial direction to south, but in order to guard from calling get direction immediately, I'll just have this extra Boolean flag. That's so ugly. That's so mean as well, because like, I'm being really annoying. Don't tell me I'm stuck in a while loop. Oh, okay. Bit slow, but it's alright. Oh, I'm so annoyed. I actually could have gotten that in after 2. I feel like that bug, this idea of like, yeah, setting it to east, but then it breaking because like everything's mod 0, it should say south. That bug I probably wouldn't have seen by myself. But the first 2, oh my goodness, I can't believe I just got the formula wrong. Firstly, I literally just did like, this wasn't even this. To be fair, this wasn't actually correct. I didn't think hard enough. I should have. I don't know. I have the diagram on hand. I should have just used it anyway. Get position. Wait, what? Whoa. It's better to. So get direction is just a field. Get position, you actually have to do stuff. Cycle length, so you figure that out. Okay, fine. If 2 times that minus. If 2 lots of self width plus height is less than. Crazy. What's pos in cycle? I guess like I'm assuming you label 0, 1, 2, 3, 4, 5 like that. And like, because you, yeah. Same kind of thing here. Pos and cycle plus, sure. Oh, that's smart, yeah, I think. So you label these numbers 0, 1, 2, 3, 4, 5, and then you get the position, and then you convert that position 2 times self width plus self height minus 3. It's a bit random. Where did that come from? 2 self width plus self height. 2 lots of self width plus self height is less than the self position. Or self position in cycle is 0. So if you're back at here or something, I don't know. I'm kind of done with the question. I'm annoyed at myself. It's not a good leak code. To be fair, acceptance rate is pretty low, but I'm assuming that's just everyone making silly mistakes. If modulus can help you, yeah. Maybe I didn't have to do. Yeah, I think this idea of like this guy where you give each cell a number and you just use the mod to figure out what number you get to. That's probably smarter than doing a while loop. But yeah. The Boolean thing's like a massive hack. I feel like I shouldn't have had to do that. Can I slightly modify this code to not have to use a Boolean thing? I don't know. Ah, it's whatever. Basic idea was there. What? Oh no, yeah. Mine's also O1, right? It's just more dumb. Because I mod and I do maximum 4 loops or 5 loops through the like 1, 2, 3, 4, 5.